at least to a point where I think if you needed help, you can do it on your own. All right, so here we got the base, which is 5. Now, whatever the log equals is the exponent. So that means 3 is the exponent. So for this one, you can just quickly switch it, and then you're done. And that one's not too demanding if you know what to do. And then the next one, we have a log equation, but the variable is the base. Now, maybe you can look at that and kind of figure out what x has to be, because we know 3 is an exponent. And so if this is going to be a whole number, this 8 has got to be related to something that has a 3 exponent. But if that's not something you're good at, you can just go ahead and switch this around to the exponential equation. So the base x has the exponent of 3, and that equals the value, and now you can finish the problem, right? So notice that if we do this, we could write this as 2 to the 3rd power, right? And now when you take the 3rd root, you get 1/2. Okay? And then we got the 3rd one there, which is a similar problem. It's just the variables in a different location. Okay, now again, if you can interpret this, we're looking for the exponent, and since the base is 5, if x is a whole number, then we're going to have this as 5 to some integer power. Now, again, you can think of it that way. But if not, go ahead and switch it around. So we got the base 5, and the log equals x, so that means that's the exponent. And we're trying to get 625. Okay, well, this is 25 times 25, which is 5 squared times 5 squared, right? And so this is 5 to the 4th power. Okay, so x would equal 4. All right, and then the first exponential equation we got shows up on number 100. Okay, and the thing with these kind of problems is that there's a little variety sometimes in how you go about obtaining solutions, right? Don't get into the habit of always doing the same technique, okay? That's, in general, not a good idea in a lot of things. So what I would do with this is I don't like negative exponents, so I'm going to flip this around. Okay, now you can just cross multiply, or you can kind of see the only way this would be equal is if the denominators are the same, because you already got the numerators the same, right? So then we can just solve this. And now that's a little more manageable, right? That's what I would do. Okay, and so now we can go ahead and switch this around to the logarithm. Now maybe you wanted to do that here. So negative 2x would be your exponent, and the value is 1/3. Okay, so I would do that here. Okay, so notice now 2x is the exponent, and the value is 3. The logarithm is going to be based on the e, so we use ln. So 2x equals the ln of 3, and then you can finish it from there. Okay. Let me pause for a couple seconds. All right, so then looking at the 104 problem, now of all of these, that's probably the one that's a little more challenging. Okay, and so with that one, we're going to rearrange it to the exponential, but then we're going to wind up with some quadratic. Okay, and here the base is 5, and whatever the log equals is the exponent, so we're going to have 5 squared equal to the value, which is quadratic, and then you just finish that problem. So you just finish the quadratic formula, right? So minus 25, so this is going to become negative 21 for your C value. Now it's not factorable, so you're going to have to do the quadratic formula. And the thing with the quadratic formula, because you're going to get two results, one with plus or minus, right? If what you substitute in here makes this negative, then we have to exclude that solution. Because remember, log of negatives are illogical, right? Because that means we could apply an exponent to a positive number and get a negative. Okay, so that's one thing you might have to check with this one. Okay, and then the last one. Now, when we're solving these equations, we're just rearranging from exponential to logarithmic or from logarithmic to exponential. We're not really using any particular properties. There are properties we're going to look at today, but it's not necessary always to do things just by applying properties. Sometimes switching things around is a lot easier and quicker. All right, so when looking at this, I would go ahead and simplify this first. So I'd divide by 8 first. That way we get the base with an exponent equal to something. Okay, now we can switch it to the logarithm. Since the base is 10, the log would be a common log. Our exponent is 2x minus 7, so the log of 3/8 equals 2x minus 7, and then you can finish it from there.